Okay, everybody, this is a snapshot on working with the standard normal table. Again, it is suggested you work the problems and watch the video by pausing it, okay? Anyway, it is assumed that you are familiar with working with the normal distribution, the theory behind it, that sort of thing. In particular, what we refer to as the standard normal, where this is a normal distribution that has a mean equal to 0 and its standard deviation is equal to 1. Normal distributions have a bell shape to the graph that can help out. The table will tell us the probabilities that z is less than a number. So the important thing about the standard normal is that we have a table we can work with in order to compute probabilities. But you have to realize that the table is telling us the probability of being below a particular number. So if I have a number z, the table is telling me the probability of being below that number, which is the area underneath the graph. But again, we do not have to calculate the area. We are going to be working with a table. Okay? Again, here's what the table looks like. We're going to be working with that. Now again, the only thing we need to keep in mind is exactly what the table is going to be telling us. So there are three basic scenarios that we're going to work with. And if you understand these three scenarios, you should be able to work any particular problem. All right, the first one is we want the probability z is less than 1.23. So we go to the table. In the left-hand column, we have the z value, what we refer to as the z-score, up to the 10th decimal place, right? The 10th decimal place. The columns, each column is associated with the hundredths position. So we're looking up 1.23. So we look up 1.2. We have it right there. Then we go to the column that is associated with the hundredths position, which is 0.3, right? So we have 1.23. We look up the tenths position. That's going to be the row. The column is given by the hundredths decimal place value, which is 3. So it's the fourth column here. And if you look at the number is 89. Let's see, 1.23. Yeah, 1.2, 1, 2, 3, here. 8907. So the first one is 0.8907. Now the next one we have to look up z of minus 1.23. Now this is a negative, so we're looking up minus 1.23 in the table. So we're going to have to go to the other side. We look up minus 1.2, the tenths position. Our column is the column associated with 0.03. So 1, 2, that's 0, 1, 2, and 3. So if you look up here, 3. So 0, 1, 2, and 3. So here it is, 10.93. 0.1093. All right, so continuing on. So we know that particular value, going back to our problem, is 0, sorry, I got to erase something, 0.1093. Got it? Again, this is unedited. You use it, that's your own risk. Okay? Next one, z of 0.05. Again, this here is exactly what the table is telling me, the probability of being below a particular number. So I'm going to look up 0.05 now. That's going to be on the other table here, 0.05. So I'm in the first row here. The hundredths place is 5, so there's my value there, 51.99. 51.99. And then the last one here. Again, all of these are less than a number, so that's the first scenario. 217. So I'll look up 217 in the table if my pen's going to work. Let me get my pen working again. All right, so 217, that's what we're looking up right now, 2.17, and looking it up in the table. 2.1 is right here. This 0.07 column is going to be, well, 9850. So that's going to be 9850. 0.9850. So that's the first scenario. First scenario right there. Second scenario, moving on. The probability we're above a number. And so I'm not going to do this for each one, but you can always draw yourself a nice little picture here. Okay, this is the scenario. We want to be above a particular number. So we're looking for this area or this probability, right? Well, if you think about it, this area here is opposite this area right here, correct? Well, opposites, their probabilities have to add up to 1. So what we're going to do is we're actually going to look up this number in the table, but we're going to be subtracting these items from 1. When we find that number in the table, we're going to subtract from 1. Because again, these are probabilities of being above a particular number. Got it? All right, so again, we look up 1.23 in the table. If you look up 1.23 in the table, 1.2 right here. And then look up 0.3, 8907. So we have 8907, so we're going to be subtracting 8907 from 1. Okay. In the next one, we're going to look up negative 0.2. Here's negative 0.2. There's no hundredths position. And so it's 4207. Next one, we're going to look up 2.81. Again, 2.81 in the table. Look up 2.1. No, I'm sorry, 2.81. 2.81, caught myself at least. All right, so when we look up 2.81, it's the hundredths position is 1, so this is a second column. Remember, just keep in mind, first column 0. Okay, so that's 9975. 2.81 is 9975. And then the last one, 4.17. Now, if you look at our table ends at 3.4. Our table ends at 3.4. And the table tells us our particular value being below it is 0.9998. Okay? Well, the number we're looking for is 417. And 417 is up here somewhere, right? So the area that 417 consists of includes 9998, but is actually more. So I suggest anything above the table, assume the amount below the table, below that particular number is 1. I'll repeat. If you are at the top end of the table, okay, then your assumption can be the probability of being below that number is 1. Okay, so we're going to assume that this here is 1. So then you take out your calculator and you can do your calculations. So if I did my calculations right, the first one should be 0.1093 for the answer. For the second one, 0.5793. For the third one, 0.0020. And then the last one, 0. So again, this is the second scenario. The probability that Z is above a particular number. Once again, that's the scenario where we subtract from 1 whatever the table gives us, right? Then the last scenario. That's actually, I didn't fix this here. See, we got a little typo. I'm catching a few things. But anyway, the probability being between two numbers. So here's the idea here. We have the graph. We have one number. We have a second number, and we want the probability of being between the two numbers, right? Now, basically, gotta move something out the way here. So basically, this is what we know. I'm gonna use some color here. The table tells me everything below this particular number, right? The table tells me everything below this particular number, right? Well, we're looking for the area in between, right? That's the area we're looking for right here, correct? Well, if the table gives me this number, maybe I should have used blue, right? And the table tells me this number includes everything I want but more. And that means it includes too much. What does it include too much of? This number here, right? We don't want this area down here, correct? Right? But this here includes all of that. So we want to get rid of this, so we subtract. Okay? Got it? That looks pretty good. Anyway, let's move on and get this done. So we need the probability of being between 1.1 and 2.2. I'm not going to go back and forth to the table now. Hopefully I picked out the correct numbers for you. If not, just let me know, and I'll send a revision or a correction notice. But again, when I look up 2.2, I get 0.9861. When I look up 1.1, I get 0.8643. Again, I want to be between these two numbers, so I subtract the smaller from the larger, and I'm going to let you do the math, or well, I'll fill it in later. Let me just stay focused here. Again, here's the scenario where I want to be between two numbers. When I look up 1.2, I will find out that it is 8849. When I look up minus 0.1, I see that it's going to be 0.4602, and then I'm going to do the math to calculate the difference. The next one, again, I'm between two numbers. I look up the 225, I get 0.9878. I look up minus 1.1, I get 0.1357. I do the math, and I get the probability of being between these two numbers. So those are the three scenarios. Let me get your numbers here for you. Okay, so they magically pop up just like that, right? Anyway, the first one, when you take the difference, it's 0.1218. The second one, 0.4247. And the last one, 0.8521. So the three scenarios: between two numbers, the larger percentage minus the smaller percentage. Above a number, the opposite, so 1 minus what the table gives you. And then the first one, the probability of being below a number, it's exactly what the table tells us. So I hope this helps. You need to be able to work with the table. Oh, wait. Surprise, I got some surprises here. I forgot about these. Okay, these are really opposite type problems. Now, I haven't really talked about them in class. They don't occur too often, but I am going to bring them up because you will see them, and there may be occasion where we need to do something like this, all right? But what this problem is doing is actually telling you the area, and you want to find the score that is associated with this particular area. That's what it wants, the z-score associated with the area under the graph. So for the first one, you got to keep in mind what the table tells you, everything below a particular number, right? Now, this is the area above it. So the area right here below it is going to be 1 minus 0. I think that's 89. I wrote over it. 0.8962, and so that area is equal to 1 minus 0.8962, 1038. So what I'm going to do is I'm going to go to the normal table and look up the area or the probability 1038. So I'm going through this table here. I'm actually looking through here. See, 1038, it's right here. There's 1038. So the z-score is a negative 1.2 with a 100 place position of 6. So negative 1.26. Do you follow me? Here I am giving the area underneath the graph. I want the z-score associated with this. Well, again, you got to keep in mind what the table tells you. It tells you everything below a number. So, opposites in this case. 1 minus this area is the area underneath z, meaning I'm talking about this area right here. It's 0.1038, but in the table, now I'm actually going to work backwards because I'm going to look for 1038. I found it. I go backwards for my z-score, right? Now, second one. This one here is between two numbers, right? But I know if I look in the table, you do it, the area below this one is 0.5. So the area below z is going to be actually these two numbers added together, because I want the number z such that I know the total area below this is 0.5 plus 0.4066. So look up 0 in the table, you'll see it's 1/2. That's just a fact for all normal distributions. The area below the mean is going to be half. Anyway, so I'm going to look up the area 0.9066. 0.9066. I'm looking for the area, meaning probability. And I look up 0.90066, and there it is. Let me get my color marker out. There it is. So looking backwards, 1.3. Looking up, 0.2. So that particular number, the z-score here, z here is equal to 1.32. Now, I forgot to put this one down. The z-score here ended up being minus 1.26, okay? So from the last problem. Okay, again, another one. Here we know the area above z is equal to 0.0239. We don't know what the area below it is, but again, these are opposites. And so opposites means that this area here is going to be 1 minus, fix my pen, 1 minus 0.0239. You erase that and write that better for you, right? You're getting good at this. 0.0239. When I do the subtraction, I get 9761. So again, I'm talking area here, not the z-scores. Don't confuse them. In all these problems here, we're looking up area right now. We're working with area. We're going to go look for the z-score now, as opposed to the earlier problems where we had the z-scores and we looked up the area, right? So this one we have area. The area is 9761. So I go to the normal table. I try to find 9761. Well, I found it. And it's associated with 1.98. 1.98. So the z-score here is 1.98. And the last one. Finally, the last one, right? Well, once again, I want this area. I have to think about it. The table is going to give me this number. The table will give me this number, right? But I know the area below 0 is 0.5. So the area below 0 is 0.5. If I subtract off 0.4176, I'm going to get the area that I'm looking for here in green. In other words, this is going to be equal to, if you subtract 0.0825. Once again, we're working with area here. I know from the table that the area below 0 is 1/2. Right? I know the area here in the shaded region is 0.175. This total has to add up to 1/2, so if I subtract this one from 1/2, I get the area. That is what I need to know. Now I'll look up 0.825 in the table. 0.825 in the table. Get my marker ready. 0.825. 0.82. Wait, it's not there. Look at that. 0.823, 0.838. Well, I'll just take the closest number. See, that one's not actually in the table. So I just grab the one that's closest. And so the closest thing is -3, -1.39. -1.39. So Z here is -1.39. I hope you enjoyed the video. One day I'll add some music for the background, right? Okay, anyway, that's probably down the road a bit. But anyway, I think that's it. I hope this helped. I'll rewind here to kind of walk you and show you the answers here. There's the answers to the first one, answers to the second one, and third one, and the last one, right? All right, so wish you the luck. Hopefully this helps. Let me know. Again, use this at your own risk. Never know, I might have a little error there, looking up something in the table, that sort of thing, but just please let me know. The theory's correct though. Okay? Thank you.